Okay, we have two more examples. Okay, for the Thevenin equivalent circuit, and here is the first example. To find the Thevenin equivalent circuit for this circuit, as you can see from this circuit, we have both independent source and dependent source. Okay, and we want to find RTH and VTH. Okay, first we will calculate the RTH, and to calculate RTH, okay, with dependent source, we first let independent source be equal to 0. So here is open circuit, and then we can apply either a voltage source, okay, and find the resulting current. And RTH is VO divided by IO, okay, the input resistance looking into these two terminals. Or you can apply current source and you find VAB, the terminal voltage, and then take the ratio. You can also get the same answer, RTH. So let's look at first how to find RTH. Okay. So here we apply voltage source. Okay, here is a numerical example, or you can just VO. Okay, because finally you will cancel out. Okay, suppose we apply 1 volt, and then you have to find output current, and then the ratio voltage divided by current to get the RTH. So let's see this circuit. We want to find the IO, okay, in this direction, and VO is 1 volt. So how to calculate I/O? You can use any method you have learned from this textbook so far. Okay. Say for example, you may use only series parallel equivalent resistance, or Y delta transformation, or node equation, or mesh equation, or whatever. Okay. Any method you can use to find I/O. Okay. And then the ratio is RTH. For example, here we use the mesh analysis. Okay, in this circuit we have 3 mesh, I1, I2, I3. Okay, for first mesh here, we have this voltage equation. Okay, and you can see we move mass 2Vx to the other side and divide by 2. We get Vx effect equals I1 minus I2. Okay, however, from the dependent source, okay, you can see the controlling parameter Vx is the voltage across the 4 ohm resistor here, which is equal to I2 minus 4, but with minus sign because the mesh current direction is clockwise direction, so from minus to plus. However, Vx is from plus to minus, so we have minus 4I2. Okay, and then we substitute I1 minus I2. We can find I1 in terms minus 3I2. And similarly, we have 2 other mesh currents, or loop 2 and loop 3, or mesh 2, mesh 3. Okay, this mesh we can write KCL equation, KVL equation, summation voltage drop along this loop equal to 0. And similar for the third loop, so we obtain 2 KVL equation here. So 3 equation, 3 and noise, we can find a solution. I/O current, in fact, is you see, I/O current is equal to minus I3. Okay. So we have I/O equal to 16 ampere, and then the ratio of voltage divided by current, we obtain the desired solution. The Thevenin equivalent resistance in this circuit is equal to 6 ohm. Okay, so are there any questions? How to find RTH, okay, for a linear 2-terminal circuit? Okay, if no problem, we have to find the second component of the Thevenin equivalent circuit, namely the VTH. Remember, the physical meaning of VTH is the open circuit voltage. Okay, since AB terminal here, okay, it's open, so there's no current to the 2 ohm resistor here. So 0 ampere times 2 ohm, okay, 0 volts drop here. So VAB in fact is equal to the voltage across the 6 ohm resistor. Okay, so here we can use simply mesh analysis to find I2, and then we can find I2 times 6 ohm, which is equal to VTH. And further examination, we can see, well, although we have 3 meshes, however, there's one current source. So in fact, you have only 2 unknowns to be solved instead of 3 unknowns. And fortunately, in this example here, I1 is equal to 5 ampere. Immediately, you obtain the solution. So you have 2 unknowns left. You have to write 2 KVL equations like this. Okay. Again here, because we have one dependent source, so we need one more step. You have to express the controlling parameter Vx in terms of I1, I2, I3. So what is Vx here? Vx in fact is equal to I1 minus I2 times 4 ohm. So we can express Vx in terms of I1 and I2. So once we substitute the controlling parameter into the equation, then we have only 2 unknowns left, and we have 2 equations. So we can find I2 equal to 10 over 3 ampere, okay, and then you multiply 6 ohm here, you get the voltage, the open circuit voltage, which is equal to VTH. So our final answer is this simple equivalent circuit, which contains only one independent voltage source called VTH and one single resistor, 6 ohm. Okay. So are there any questions about finding the Thevenin equivalent circuit? 好，在单位零等下电路呢，这是非常有用。It's very powerful, I mean very useful tool. Okay. Normally, you may have to solve a very large scale circuit. Okay. However, in case you can use the Thevenin equivalent circuit, you can focus on the small circuit and let remaining circuit be replaced by the Thevenin equivalent circuit. So you only solve a very small scale circuit. 这在设计的是非常有用，你可以聚焦在你那个小的电路里面去设计，其他那个可能非常大的 circuit， 你用一个单位等效电路就把它取代掉。不管在计算、在设计的过程，可以简化很多工作，所以这个定理各位一定要懂不然就是电路学等于没有学过了这是我们很重要的一个教学目标。Okay, now let's look at the last example of Thevenin equivalent circuit. Okay, here is the problem. Okay, and we want to determine its equivalent. Looking into AB2 terminals, and as you can see from this circuit here, we have only dependent source. So for this circuit, we have a trivial solution. Because there is no independent source, and what is the open circuit? This is a dead circuit, 0 volt. So you immediately know the answer VTH equal to 0. 这题是送分的一半因为我们单元等下电路只有2个 component 你要算，一个 VTH， 一个 RTH， 这里面都没有 independent source。这个男主角、女主角都不见了，都没有戏唱，所以这个 VTH 等于0。Okay, the trivial solution. And how to find RTH? Because we have dependent source, so the only way you can apply either current source or voltage source. So for this example here, we give you an example. We apply current source, and we have to find VAB, and then VO, okay, or VAB divided by I0. You can get your answer, RTH. 这个 dependent source 就简单是加一个电压和求电点， 或者加一个电流除电压，这两个这是 equivalent RTH 的定义，电压除电流。So for this circuit, we can use the node analysis. We assume this is the data node. Then we have only one node voltage called VO, V0 here, and we can write down the Kirchhoff current law. So the current entering to this node VO is IO plus minus 2IX, or it moved to other side. That's okay. Plus IX here, okay. And the current limit this node is VO divided by 4 ohm and plus 2IX. 左边是流进这个节点的电流，右边呢是流出这个节点的电流，它们是相等的。所以 we also need to find the expression of IX. The controlling parameter is IX. However, R and O is not the voltage VO. So how to find IX in terms of VO is quite obvious here. VO divided by 2 ohm is the current downward, so which is equal to minus IX. In other words, we have IX equals minus VO divided by 2 ohm. So we substitute into the expression here. Okay, we can find the ratio VO divided by IO. See, here is a very interesting point. Okay, the equivalent resistor is with minus sign. Okay, by using passive sign convention, you can find the power is equal to negative. Is a negative value, which means it dissipates negative energy, negative power, or in other words, is a source, like a generator. It delivers power, okay, it generates power. 这负电阻的意思是，它不是消耗能源，它是一个发电机，它是产生能源。Okay, so this is the last example here. We have, in fact, 5 examples. So, any question? In the second master test, there's a certain, at least one problem is related to leveling equivalent circuit. 因为这电理是非常重要，所以非常重要是对你们将来非常有用一个电理。其实这个 philosophy 是很重要的各位同学将来你在做研究或者开发新产品，同样的观念比如说我们电力系统，从台北到台南到高雄这么大的一个系统，那突然发生一个短路，可能某一个地方一部吊车一不小心碰到那个输电线，造成短路，它只是在 locally 发生在那边，所以你不必要解全台湾的电力系统 ，it's too complicated. It's very large scale system. So in that case, normally we reduce the remaining last system. How to do that? We use a equivalent circuit. So the concept is quite similar to the Leveling equivalent circuit. 我们再举个例子，我们的成空湖那么大，如果你拿一个石头丢砰一声，连拨一圈一圈那你要这流体动力学要波动力学，整个成空湖那么大，那块石头只有附近那边才会受影响，所以你其他的部分你可以用一个 equivalent 的一个 model 来取代。所以同样的观念，你可以用在将来你的光电、通讯、物理或者机械系统各种系统这是所以我们讲说这个周教你一法通万法通所以各位同学读书要会融会贯通你这样子会这样想的话，你将来毕业以后你解决你这些各方面的问题非常有帮助。